So small modular reactors is another area which is a discussion that comes up periodically. And in the UK at the moment, we are going back and thinking about small modular and micro reactors. Again, there are lots of ways you can describe that, but it really all comes down to, can small be beautiful from a business case point of view? And this really is access to finance for the reactor. And small reactors do cost less. Can that really make the difference and create a business from an SMR point of view? There are loads and loads of different designs. There's the, I'll just put a few down. The IRIS International Reactor, Innovative and Secure, the Atoms for Peace Reactor, the Toshiba 4S, which is super safe, not just safe, super safe, small and simple. And then in the UK, for example, we've got a new battery design for local energy, which is only 4 megawatts electric, which actually does use TRISO and for helium cooling, which will be familiar for PBMR aficionados here. So the only thing they really all have in common is they have these fantastic names. You can't have it seems to be a characteristic of these types of reactors, you've got to come up with an amazing name for it. But, I mean, PBMR was beyond this. PBMR was modular, but I don't think it was quite small. What was the how many megawatts electric?
165.
Oh, it was 160. Okay. Do you think there's any? Can I ask? Be naughty and ask the question. Is there any chance that South Africa will go and look at that design again in the future, or do you think that now is absolutely line and under with it?
My personal view is I was the project leader.
Oh, were you?
Of that project. I was the CEO. I started the project. Right. It has died for many reasons. We'll go to those. I do not believe it is possible to restart it as it was. What I think is most interesting at the moment, economically, in the small, and everyone's ignoring this, but the Chinese are building 2 TRISO.
They are.
It is an indirect cycle machine. But if you look at their costs they're claiming for building those, it's not that much more than they're claiming to build the Gen 3 reactors per kilowatt. And that's the first 2. So there's an interesting line to watch in the Chinese with this. But I don't see a prospect in South Africa of the PBMR as it was being restarted.
Interesting. Yes, China's. Yeah. China is really at the forefront of so many of these sorts of projects. Although my understanding is that even at the rate at which they're building reactors and will continue to build reactors, it's only going to still make a few % difference to their entire electricity generation. For us, when we start the new build process, we are, and again this graph is a couple of years old now, so we aren't in fact at this point. We thought we would be building by this point, so we've got to shift it over by 2 or 3 years. But the skills gap that we have in the UK, particularly at the apprentice sorts of level, is really severe. This is going to be quite a challenge to us. With the projects being delayed a few years, it has, however, given us a chance to really develop the academic community, and I'm going to talk to you a little bit about that in a few moments. And we've also started to get apprentice schemes up and running. So I think we will be able to deal with this, but it's going to be it's serious. So how have we gone about developing our nuclear research R&D needs? Well, in the classic British tradition, we've written a lot of reports about this. There was a Royal Society report, the House of Lords report, for which I was the specialist advisor for that, which was a really fascinating experience. The concept of asking for collecting evidence from a parliamentary point of view and comparing and contrasting that with evidence from a scientific point of view and evidence from a legal point of view. And the use of the word evidence, I now appreciate that is quite different. All legitimate, but quite different ways of thinking about things. And I really found that interesting. So the House of Lords report Long-term strategy was needed for nuclear energy in the UK. I'm sure you've heard that in many countries, the idea that the long-term strategy is missing, and also an R&D roadmap and the establishment of a nuclear R&D board. We then had another committee which went through, I was a member of this one as well, so the UK's nuclear future. The government accepted the recommendations in the House of Lords report that we dropped the ball somewhat, and this reported to government in April 2013, and of the recommendation, well, you can see here, I should point out, that we looked at the strategy, landscapes, roadmaps, industrial vision statement, and so forth, and the recommendations of this. There are numbers of recommendations. The board going to come in the health and industry puts in place a new R&D skills program. The board of the government of health and industry puts in clear plans to retain development skills capability. So that really started that out. And from my point of view personally, I was absolutely delighted that we got 15 million quid to buy lots of new active facilities, because the thing we were really in problems with for our students is we didn't have access to carry out active work. And as many of you will know, doing a PhD or a master's or an undergraduate in which you don't actually do any work with real active materials, I don't think prepares you properly for a life in the nuclear industry. We lacked that, but we got 15 million at that point, and I'm delighted to tell you that we've secured an extra 60 million to go forward with that, and I'll talk about that in a little while. We also joined the Jules Horowitz test reactor program as a minor component. So we then developed this thing called the Nuclear Industry Research Advisory Board, and it does what it says on the bottle. It is, however, unfunded with respect to actually research activities in industry and university. It is only an advisory board at this stage.
So just a quick question. You mentioned fast reactors.
I did.
Can you just elaborate a little bit on fast reactors and where in your roadmap does it take into account, or is UK still looking at fast reactors?
So in our roadmap, fast reactors are not on the agenda in the short term. In our roadmap, we believe that fast reactors could play a part further down for much higher uses of the nuclear fuel. So you appreciate, I'm sure, that you can use up something like 70 to 80% of the uranium atoms in the fuel in a fast reactor, whereas in a conventional light water reactor you use about 3% of the uranium. It also, with the fast neutron spectrum, you can burn up the long-lived actinides, so that the inventory of waste you get at the end has a much lower proportion of those, so that the geological burden is much less. So I'm personally a fan of fast reactors, as you can see, in an integrated fuel cycle, but I think we're a long way away from implementing that, and it is at the moment only an option for the UK. So we've sort of kicked it down the road somewhat, probably a decade at least.